Therefore, the time required for computing the matrix multiplication T of n is given by, there are 8 multiplications that are happening, each of each of the matrix of size n by 2, plus this is about multiplication. What about addition? So we know that in the matrix addition, what is the order of growth? I mean, what is the asymptotic notation of matrix addition? Matrix addition is of how many for loops? 2 for loops, as you can recall. So therefore, of the order n square, isn't it? And in this case, we have 4 multiplications that are happening, and if you take the larger sized matrices, again the number of additions will increase. I mean, 4 additions that are happening, and if you take the larger order matrices, then the number of additions also increase, and hence I can now write, in this case it is 4 additions that are happening, and I will directly write the order of growth for matrix addition, that is n square, and instead of 4 now I replace this with some constant. Okay, because this constant is in this case 4 additions, and in another case it may be 16 additions if you consider the 4 by 4 matrix, like and so on, and hence I replace this value with some constant. See, anyhow that does not affect the order of growth. Okay, now you compare this with the master theorem. So this is f of n. Okay, and f of n belongs to big theta of n square. Therefore, value of d is equal to 2. Next, consider this: a is equal to 8, b is equal to 2. Okay, so what is the relationship between a and b to the power d? So a is 8, b is 2, d is 2. Okay, so 8 is greater than 4. So if that is the case, then the order of growth of t of n will be, t of n belongs to big theta of n to the power log a to the base b, which is nothing but big theta of n to the power log 8 base 2. What is log 8 base 2? Log 8 base 2 cube. So it is theta of n cube. Correct? Theta of n cube. And that is what we already know about the order of matrix. Okay, so how Strassen reduced this amount of time, the n cube? So in the Strassen's matrix multiplication, the time required to compute the matrix multiplication is slightly less than n cube. Okay, and how Strassen applied a method to make this as less than n cube? So let us see that. For Strassen's multiplication, refer the second textbook, the textbook by Sahni. Look at the page number somewhere 181. Okay. So he has derived some formula: P is equal to A11 plus A22 into B11 plus B22. Then Q is equal to A21 plus A22 and into B11. Next, R is equal to A11 into B12 minus B22. S is equal to A22 into B21 minus B11. T is equal to A11 plus A12 into B22. U is equal to A21 minus A11 into B11 plus B12. V is equal to A12 minus A22 into B21 plus B22. And this matrix element C11 is given by P plus S minus T plus V. C12 is given by R plus T, and C21 is given by Q plus S. C22 is given by p plus r minus q plus u. Okay, you will have to remember these equations. This is required to solve the examples. In the previous exams, few questions are there on the Strassen's matrix multiplication. I mean, given 2 by 2 matrix, you will have to compute by applying the Strassen's method. I mean, you have to compute all this, you have to then calculate the these things, C11 and C22. Can you now count the number of additions and multiplications that are happening with this Strassen's method? Yeah. Count the number of multiplications and count the number of additions. There are totally 7 multiplications and 18 additions and or deletions, subtractions, additions and subtractions that are happening. Okay, so if you recursively apply for some matrix of order n by n, then T of n is given by 7 multiplications and each of the submatrix of size n by 2 plus. So additions and subtractions I will I mean in this case take 18 and another case it will be another value, therefore I will take C, and the order of growth is n square, which is f of n in this case. Okay, so f of n is belongs to big theta of n square. I mean the d value is 2. Apply the master theorem. A value is 7, b value is 2. Okay, therefore T of n belongs to big theta of n to the power log a to the base b. So which is nothing but n to the power log 7 base 2. What is 7 base 2? N to the power 7 log 7 base 2 is nothing but 2.81. Therefore T of n belongs to big theta of n to the power 2.8. 2.8. Okay, so obviously n to the power 2.8 is less than n cube, right? So when the order of matrices goes high in the small, very small values like 2 and 4, it does not make much difference, but when the order of matrix takes the value higher at higher side, then n to the power 2.8 will be a very smaller value compared to n cube, and this is what Strassen's matrix multiplication.